In 46 through 54, refer to the Tarski world given in figure 3.1.1, which is shown again here for reference. The domains of all variables consist of all the objects in the Tarski world. For each statement, part A says indicate whether the statement is true or false and justify your answer, and part B says write the given statement using the formal logical notation illustrated in example 3.3.10, and then part C says write a negation for the given statement using the formal logical notation of example 3.3.10. For every object x, if x is a circle, then there is a square y such that y has the same color. So we're making a claim about every object x. However, the proposition after the quantification is an if-then statement. And an if-then statement only needs to be verified for when the premise is true. We don't need to consider instances in which the implication is automatically true. So because of that, we're only going to check if this statement is true for circles. So starting with circle B, we have to ask a question, is there a square y such that y has the same color as x? And in this case, the answer is yes, there is a square here that we can label as y that has the same color as x. But this statement is quantified for all circles. So that means we have to check this circle as well. And if you could tell, this circle does not have the same color as any square. There are no squares that have the same color as circle D. So this means part A is false, and that's because circle D is a counterexample to the implication. Circle D satisfies the hypothesis of the implication, but does not satisfy the conclusion. And so since the premise is true and the conclusion is false, the implication is false, and D is the corresponding counterexample. Part B, we have to write the formal logical notation. We start by saying for all x, that corresponds to for every object x. Now, if x is a circle, you would say circle of x. This propositional statement is true exactly when the input is a circle. So circle of x implies there is a square y, so we would say there exists a y, such that first we have to say that y is a square, so we would say square of y, and y has the same color as x, so we would say square of y to signify that y is a square, and then x and y have the same color. And then we close all of our parentheses, and that's the answer to part B. For part C, we have to negate this. So we start by turning this universal quantifier into there exists. And now we have to negate an implication. The implication is false precisely when the premise is true and the conclusion is false. So we would say not circle x. And now we have to negate this conclusion. So we start by swapping the existential quantifier to universal. And we have to negate this and operation, which according to De Morgan's law says we have to negate each component and flip the logical operator. So either y is not a square or x and y don't have the same color. Thanks everyone, and I'll see you in the next video.